So hey everybody, welcome back to the channel. I know I haven't been consistent in uploading the videos regarding this introduction to communication systems, but since I got little time to make this video, I'm making this. So finally, let's dive deep into the subject. In the last two videos, I've discussed about the evolution of the communication systems and a layman analysis of what is meant by time and frequency. Now, I think this is a very important time for us to dive deep into the subject about knowing what is meant by signal, and getting to know better about signal would actually gives us so much of scope to get into the subject with more of the details in the future. So let's get into the subject. So what is meant by a signal first? So the name itself is telling signal analysis. So what is meant by signal? So most of the people will be thinking about a signal is something which we see as a graphical matter and graphical analysis that we see in textbooks or in some mathematical equations. But what does it actually tells you? What is the intuitive nature of a signal analysis? So to make somebody understand the beauty of signaling and what is meant by signal, first we need to understand a process. Anything that is happening around you has a meaning to it. I'll get into the subject with signal by telling a little example. Now let's take you have a bike and you have to go to a college. Now going to college is not simple. You have to go to your college passing many hurdles, many speed breakers, and most important thing is going to college in the traffic. Now if you're going in the traffic, you will have signals. What signals? Traffic signal. Let's take you are not somebody who is not having any idea about any terminologies, any subject. But as soon as if you see the red light, you are going to brake. What does it mean? It is telling you some information that you have to stop at this point. That means there is a clear indication that you have to stop. Now, at the same time, if you see orange light, you will start your vehicle again, and if you see the green light, you will move ahead. That means there is some process that is going on in the nature around your surroundings, which is telling you some information or giving you some idea that you have to do this, you have to do that. Similarly, the process that you are able to understand even without knowing it, if you are able to represent it on a paper or on something which somebody can understand, is basically a signal. Let's take some random thing which you are able to explain to somebody. But if you are able to tell this random thing to somebody by putting it on a paper through mathematical form or in a way that somebody can understand, is actually a signal. Now I know it's a little complicated, but I'll make things simple. So let's take a very simple definitions that I have made into this. A signal is a graphical representation of any process. As I've told in the last video, that anything that is happening happens with respect to time. So any physical quantity, any physical variable that you take is done actually with respect to time. So let's take temperature. Temperature variation is something which you actually feel when you go outside of your house. You are actually feeling the process and you have the idea. But if you have the ability to make somebody understand how the temperature is changing by putting it on a paper or in a way that somebody can understand through some tools, is what a signal is. A signal actually conveys some meaningful information inside it. This would only be understood if you present it in a way that somebody can understand. How can somebody can easily understand something? Since we are dealing our life with mathematics is something which we take as help in representing a signal. So a signal is something, a mathematical representation of any process that somebody can understand. And one important thing is, representing any process in mathematical form doesn't mean that somebody has to understand it. Something may be understandable, may not be understandable. That is the catch here. So a signal is something which is actually representing a process, but you are able to explain it in a form of mathematical way so that somebody can understand it and use it for the further processes. And the information in the signal may be certain, may not be certain. As I told, anything that you see, let's take temperature. I'm telling a signal as to be a process, but if you represent it in some mathematical form, it is a signal. Okay, the information may be certain, may not be certain. How? Temperature, the prediction of temperature, the process is not certain at all. And there is some process where you can actually predict, and those process that you already see is like traffic lights, and uh, this day-to-day process of sun coming up, going down, and the sinusoidal waves. These shapes are certain, triangular waves. All laboratory signals have the same shape. It's like that. So in simple, signal may be certain, may not be certain. That means the information content present inside it may be certain, may not be certain. But the main thing is, if you're able to show it to somebody in a way that they can understand through some tools, is what actually signal. But signal has a process inside it. That process may be anything, having any number of physical variables inside it, telling something to somebody. So a signal with more randomness or uncertainty has more information. Now this is a point I have to stress, because as I told, a signal is actually a process, and signal is something which you need to represent to somebody in a way that they can understand. Some people may understand it, may not understand it. Let's take, I'll talk about this first one. The signal with more randomness or uncertainty has more information. That means, let's take an ECG signal. This ECG signal is very complicated, but this ECG signal can only be understood by a doctor. So he is the person to understand it. There is so much of randomness in it. There is so much of uncertainty in it. That means the more the uncertainty, the more the randomness, the information content present in it is very complicated. The information is very precious. So this might be a little complicated, but if you see a doctor's graphs, if you see some reports, you cannot understand it. But the more the complexity increases, the more information is there inside it. That's how a signal is intuitively understood. The more randomness, the more signal content, the more information is there. If no randomness, doesn't mean no information is there, but the amount of information will increases with the amount of randomness present inside it. So just to elaborate it, I have written some more points in it. So any normal matter has less information, unusual matter has more information. Like dog bites man is a very common emotion, but if man bites dog is a very viral news. That means this has so much of viral information inside it. So the controversies will be created if something happens like this. Now this becomes the heat of the topic. So information can only be improved with uncertainties or with the changes. Okay, so signal is just a process. You are able to explain it or prove it to somebody by writing it on a paper or in a way that you can explain to somebody. So as the uncertainty increases, depth of the information content also increases. Next is now what is meant by signal? As I told you, now you are seeing a graph. Now this graph is drawn with respect to time, and let's take that is an amplitude of the voltage. I am talking, what I am talking, this is an audio signal, but if you keep a transducer in between it, this audio signal will be converted into electrical signal. Now this electrical signal can be plotted as a graph. Now the graph, by looking at the graph, what does it actually tell? By looking at the graph, the graph actually tells that my voice is being converted into some voltage form through a transducer. That is what this picture actually tells. Now, since I am talking with respect to time, whatever I am talking continuously, same pulses are converted at the same time into a voltage form. That is why these curves are there. As I am talking with respect to time, the consecutive audio signals are converted into voltage forms through a transducer. That means looking at a graph, you are able to tell some process has happened. Now, if you are able to put this on a paper by writing an equation, generalized equation, you also can call that as a signal. So simple. Let's take mathematics. To explain it better, I'll jump to this point. Now let's take, I write y equal to mx plus c. What do you call it? You call that a straight line. Can't you call it as a signal? Yes, you can call it as a signal. Just write y equal to mx, straight line passing through origin. Can't you call it as a signal? Of course, you can call it as a signal. Any mathematical expression can be called as a signal. Why? If you're able to put it on a graph, and you can put some equations, if you're able to put it and explain it to somebody in a graphical way, those are called as signals. Let's take y equal to mx. E is a straight line passing through an origin. What does it actually tell? The behavioral nature of it is what? Is a linear. There is a linearity. That means how much of input you give, corresponding output will be coming to it. So, simpler way, any mathematical form that you are able to write and express in terms of graph, and you are able to explain the process inside the graph, is something called a signal. As simple as that. So this is what I have explained here. So function, any signal has to be between two variables, right? Time or any amplitude. Time, pressure, time, some other physical quantity, temperature, like that. So signal is a function of one or more variables that conveys information about usually some physical phenomena. So as I told, my voice is getting converted with the help of a transducer, which is represented in the form of a graph. So physical phenomena is being done, is actually happening. So that I am representing in terms of a signal, which you can understand it by looking at it. You will understand some process is happening. A signal is something which is conveying some information. So like that, here it's time, and here it's voltage. But it might be time, and maybe the y-axis might be many other physical quantities also. It might be time, temperature, length, mass, electric current, light intensity, velocity, density. So if you're able to represent any graph or any process with respect to all these physical quantities, can also be considered, it's actually a signal. That's how you represent a process taking many physical quantities like that. Now let's take a very simple thing. Now we have time, we have amplitude. So a process is being generated. Now looking at this graph, what do you actually mean? Let's take a truck. I'm generalizing what is a signal, how better can you understand a signal. So let's take a truck. Now just don't consider this an amplitude, but you consider this as speed. Let's consider speed. Now I have told you that signal, to better understand a signal, is how you better understand a process, a representation of a process. Let's take, my truck has started from point A and it has to go to point B. But going from point A to point B has many hurdles, has many hill stations, many obstacles in it. So initially, since the road was good, its speed was very good. So speed started to increase. But since there are many obstacles, speed breakers, the speed has been reduced to some level. and then since the road is good, the speed is again increased, and again the road is not good, speed is decreased. Same like that, the speed is increased, decreased based on the terrain, geographical terrain. That means you are able to understand the process of a truck going from point A to B just by looking at this graph. You are able to predict the speed of the truck going from A to B within this duration of time. The speed is being increased, decreased, increased, decreased, increased, decreased. So main thing is process being represented in a graphical way that somebody can understand it, and understanding in the sense, if you are able to put it on a paper in a mathematical form or in some form that somebody can understand it, is what a signal is. So here of course the independent variable is time, because the speed is varying but the time is independent. So this I have explained you, and some of the examples of how a signal can be actually represented by taking the dimensions, the 1D signal, 2D signals is are the examples like pictures, x-rays, sonograms of 2D. So there are some 3D examples of 3D signals and 2D signals. But okay, these part we'll consider in the next video in a depth if it is required. But the only thing that I really wanted to tell is a signal is something which actually represents a process, and if you're able to put it on a paper in a way that somebody can understand, how does somebody can understand? Somebody can understand through mathematical way. So a mathematical representation of a process which somebody can understand and can be used for the further purposes is what a signal is. So I hope I have covered something regarding signal, and I'm very open to take any suggestions from anybody. I'm still in the learning phase and giving the best that I can give to my friends out there. So I hope I've done something. In the next video we'll be discussing something good and some other concepts in a better way. So meet you soon. Thank you. Bye.